Welcome back. Now, to address the question of why negative emotions materialize and have such a strong effect, we really have to understand what emotions themselves are. Have you ever wondered why your heart beats faster when you're angry? Sometimes in real fits of rage, maybe your whole body will shake. There are many other telltale signs also that become immediately visible when someone is feeling or expressing anger. I'll show you some later, but why is this? Like most things, the clue is actually in the name. Emotions are signals to move or take action. That's why they're called emotions. Picture this. Imagine it's a bright sunny day and you're having a lovely afternoon skipping through the fields picking flowers. But then all of a sudden, out of nowhere, you're confronted by a huge scary bear. What would you do? Would you play with the bear? Would you try reasoning with the bear? Or perhaps something else? Now this is where your emotions kick in. And it's because of our emotions that we, as humans, have continued to survive for as long as we have. When confronted by the bear, you typically have three choices. You could potentially fight the bear if you're strong enough and if you have weapons. Perhaps you could try running from the bear, although I've heard the bears can apparently be fairly quick when they want to be. Or you could freeze and hope the bear either doesn't notice you or doesn't feel that you are a threat and then maybe, hopefully, would leave you alone. But those three choices are our basic, fundamental survival instincts when we encounter any perceived danger. I'll go into more detail about why I use the word perceived later on. But these three basic survival instincts are our built-in protection mechanisms, and they've kept us alive throughout our existence. They're firmly rooted in our brains. The thing is, though, for them to work efficiently, they have to kick in quickly. Let me show you how it all works. Now, I know this isn't a biology lesson, but by understanding the way emotions are triggered will help you to better understand how to control them. If you're not controlling them, be sure that they are controlling you. Now, people often think of human beings as having just one brain. This is actually incorrect. We've evolved over time and our brains have developed. That is true. And so much so that the average human skull size and shape has also evolved to incorporate the brain structure changes. When examining the brain, it's shown to be made up of three distinct parts. The three parts of the brain that work in conjunction to make up what we refer to as the complete brain. Now, often when I deliver this training, people put their hand up and say, I heard something similar, but was always led to believe that the brain had two parts, the left and the right. One side is for creativity and the other side is for logic. And this is true. However, this is only in relation to the neocortex, the thinking brain. The neocortex indeed has two areas that have different functions. The other two brains, apart from the neocortex, these don't get so much attention, and until recently scientists weren't really aware of them, but now they've discovered in more detail their true functions and also their importance. So here are the three brains. Now if you look at this infographic, you'll see at the top we have the thinking brain, the neocortex, the one that I was referring to, that's commonly known to have the two sides, one dedicated to creativity and the other to logic. This is what helps us with anything that requires thinking, creativity. This is where it is carried out in the neocortex. Next we have the mammalian or emotional brain. Now the functionality of this brain is best described using dogs as an example. Dogs, as any dog owner will verify, are extremely emotional. When you come home, they're full of joy, running around, jumping on you, licking, making squeaking noises. Younger ones might even lose control and pee on the floor in excitement. However, when the owner looks over at the couch to see that it's been completely destroyed by their loving pup, the dog's emotion will completely change, and they'll either go into a mode of freeze, looking extremely apologetic at you, or they'll flee to a safe space in the house. And finally, we have the most rudimentary brain, the reptilian brain. And much like a reptile, that only has the 3 mechanisms of fight, flee, or freeze. We too have this built into us as our own personal protection mechanism. So what actually happens? How can we think so quickly to protect ourselves in times of danger, rather than potentially wasting time thinking about the situation, at which point it may be too late? Let me show you. So here we have the full map of the complete brain systems. Now, without going into too much detail, the sensory information, maybe it's from what you see, what you smell, what you hear, what you touch, our 5 senses. This information comes straight into the thalamus, as it always does. It's then passed along, so long as the information received is not perceived as dangerous by the hippocampus and the reptilian brain system. This information flows normally through to the neocortex to be processed. From there, we utilize the output information to take whatever actions we wish after it has been processed. This changes, though, when we are in perceived danger. There's that word again. Don't worry, I promise I will come back to that later. But when the hippocampus senses perceived danger, instead of sending the information flow to the neocortex, as it usually would, it instead channels it through to the amygdala. The amygdala then performs one major function. It blocks off the flow of oxygen to the neocortex and also the flow of information, thereby virtually shutting it off, or at least minimizing the flow to the thinking brain, thereby leaving only the reptilian brain and the emotional brain to process and act on the limited information that has already been received. This is known as an amygdala hijack. Subsequently, when an amygdala hijack information or cut-off of information has occurred, this typically results in a fight, flight, or flee response, because that is all that the brains know to process if there is no neocortex. And this is why we see those responses frequently when someone is in danger, whether or not that danger is necessarily true. Now, the main message I would like you to take from this module is the following. When your brain perceives that it is under threat or danger, you will not be thinking carefully or logically. Your amygdala will kick in, and unless you are aware, you too will react in a manner of either fight, flight, or freeze. Now, in the next module, I'll explain the symptoms of an amygdala hijack and show you a real-life example of it in action at work. See you in the next module.